Alright, so now in this video we're going to take an existing surface and begin to, for lack of a better term, apply some texture to it. We can do that by beginning to subdivide our surface using a variety of different types of cells or grids. So these can be square, triangles, hexagon, all sorts of different geometries. So you can have a lot of variation of how you tile it using those shapes, and then from there you can do all sorts of different types of morphing of your surface. So with this video, because there's so many options you can begin to take this, there will be a series of videos like this where I'll take you all the way to the point where we start to morph it, and then from there in the other videos I'll show you all sorts of different other types of applications, but the idea kind of stays the same leading up to that point. So again, we're starting with a height field image here. We've got this kind of swirling abstract image. If you want to reduce the kind of detailing of it, you can always drag your number sliders this way, but if you really want to give it some really kind of fine detail to it, you can see how that starts to look. You can really bump up your slider count there. So it's really kind of up to you. It's going to get reduced just naturally from the new tiling, so I usually try to keep it somewhere in the middle. So I know that it's still going to have some level of detail, but I'm not too worried about it losing that much resolution. So from this, again, sometimes once I'm satisfied with the landform itself, it's good to actually just bake that into Rhino and work from there. So that's what I'm going to do. So I'm going to, again, bake this onto a layer, hit OK. Now I'm going to use this surface and re-reference it into Grasshopper. This is one of those things where, again, I'm just trying to manage my file so that it doesn't get too laggy with every additional thing I do with it. So from here, I need to establish a parameter for my surface. I can show a variety of different ways, so it could be based off of the slope of my landform, it could be based off of the height, it could be based off of the overall surface area of these cells. Like I said, there's a variety of ways we can use to formulate these parameters to create our transformations. Again, in this one, I'll start by just showing the slope of these surfaces, because we can see that we've got really steep areas, really flat areas. It should give us a good variation in our tiling. A good plugin to get for this is Lunchbox. You can see in the panels, this is where we can get all sorts of different types of grid systems or tiling styles. So there's diamonds, hexagons, all sorts of ways to create quads or squares, and then even some triangulation. I'll stick with this hexagon one. So what's good about this plugin is that it just requires you to input that surface and then provide number sliders for each direction. I'm gonna give them their own separate ones so I can kind of play with the size and proportion of these hexagons. So you can see as I drag them in one direction, they can get really kind of long and narrow, versus if I try to double it in the U direction or the X direction, then they start to almost become more of your kind of traditional looking hexagons, right? So what's good about it is that even though they're the same number in each direction, depending on the surface type, they become distorted in some areas. So you can see here that some of these start to kind of really stretch out and morph, which is going to help give a nice variation to our surface. Let's see, I think this is just a little too dense. I'm going to drag some of these down a little bit more, but maybe I still go for this kind of square or more kind of equal size, so it's probably close to like 20. Makes them look pretty uniform. All right, so here is where we begin the first step of analyzing our surface to establish those parameters. So in this case, the parameters we're looking at are the slope conditions of our surface. So I've got these points here which are going to be really helpful for that process. So I'll go to Surface, Analysis, and in order to get that slope, we need to evaluate that surface. So it's asking for that surface here, but it's also asking for this UV parameter. And that's something we don't have yet. So in order to do that, we need to go to Analysis and look at the surface or B-rep closest point. In this case, it really doesn't matter which one you choose. So it's asking for the points, that's these center points. And then again, it's asking for the surface. And it's not going to really produce anything from that, but it does give us our UV point count. So that's what this is asking for. This is what it's providing. So I drag this into here. And now we get to see all these planes that are essentially the different angles of each one of those hexagon cells. So let's turn it off for a second. And a better way to visualize that is, again, this isn't part of the actual script itself, but I always like to do these to get a better idea of what this component is doing. So if I go to primitive and do line SDL, this is going to create a line that's perpendicular to these cells. So again, it's asking for a start point that's coming out right there. And then it's also asking for the direction. And that's what the evaluating surface is doing, is giving us a vector so that we can understand the angle of these surfaces. And I'm going to turn this off for a second. And you can start to see that these points are all perpendicular to that area. And obviously, there's a lot of different slope conditions happening in between. So it really depends on how detailed you want to tile this to show that much information. So you can see as soon as I start to increase that, I start to get more of these lines in the either direction. Almost starts to look like hair or grass coming out of your surface, which is kind of interesting in itself. If I turn off my surface and just look at it for the curves, and I go to my top view, it's kind of an interesting representation where I don't see any of those points that are directed straight up because they're essentially flush with my viewport, but the ones that are more angled and they're perpendicular to that viewport, you start to see that more distinctly, and you can see that it's still kind of matching that height field image that was used. So again, it's a good kind of representation just to understand what that component is doing, but I don't actually need it. Let's go back to this and let's just look at it for the cells. So now I can use this to determine a slope of all these different cells. So in order to do that, I need to actually measure this direction of those cells with a fixed value. In this case, if I measure the angle between this and a z vector, then I'll start to get that angle. So I'll go to vector, vector, and use angle. So it's asking for an angle to measure and what we're measuring it against. In that case, again, the unit z vector. And this is going to give me my angles and radians. It's hard to really kind of understand what angles are in radians, so we can calculate the actual slope percentage from that using some built-in trigonometry and Grasshopper. So I'll go to Math, Trig, Tangent. So the tangent of these times 100, because it's essentially giving us the slope in a decimal format. So if I do it as 100, I'm doing it as a panel because I know that this is a fixed value. I don't need a slider because it shouldn't change. That's usually kind of helps me understand, like, okay, this is a number that isn't going to change, so I don't have to worry about it, versus if I put a 100 slider in there, I might be tempted to change it if I lose track of this. But now I can see the slope of all these different cells in a percentage format. So from here, I can use that information to begin altering these different cells and points and all that. So it's from here, and I'm going to hit Control G to kind of highlight this. This is the parameter that we're going to use for everything in this script. We're using the slope to essentially determine how we're going to transform our cells. So basically working from one spectrum of where it's really flat versus areas that are really steep. And so from that, we can start to make all sorts of different adjustments. One of the first things we can do is start to maybe scale our hexagons to be different sizes. I'm going to go back to alter this to its original, so I'm just double clicking at 60 and then do 20. So I'm going to just start to change the size of these based off of the parameter, and you can apply it all sorts of different ways, and you'll see that in this video. I'll start off by having the flat ones pretty much stay the same size, but then as it gets steeper, they'll get incrementally smaller depending on that slope. So let's go ahead and do scale. So the geometry that we want to scale are our cells. It needs the center point of that, which is also getting provided from that same component. You can see that they just all by default factor to a 0.5 scale, so they're all half the size now. But like I said, I want to use the slope to give it that variation to it. So this component is looking at scale factors, one being that it stays the same size, 0.5 is half, 0.25 is a quarter, 2 is twice the size. So this is working on certain values. This is giving me slope and a percentage. So just looking at this, I see things like 75, 131, 38. If I were to just plug those right into there, that means these shapes would all be hundreds of times their original size, which is not what we want. So this is why we remap values in order to get a desired outcome. So I'm going to remap these numbers. So I need the actual source domain for this. So this is essentially the lowest value and the highest value. So I'm going to use the min and max for the bounds domain. And then it's going to just adjust it to be, so if it's really flat, it's going to scale to 0. If it's really steep, then it's going to stay the same size. So it's already kind of doing the opposite of what we want. If I want to just, again, kind of maintain a very linear interpolation, I can, again, say that A, or the low value, stays the same. Let's actually do something like 0.95 so that we see at least some change. And then the high value being something like 0.15. So when it's really steep, it gets to that scale factor. And let's just plug that in. And now we can start to see how the scale begins to factor. So again, all the really flat ones are pretty much staying the same. It's not until we get to these really steep areas that it starts to scale. But you can see that there's not a whole lot of discrepancy. So sometimes it's good to actually use the graph mapper to give us a little more variation. So we can say that, you know what, things that are between a medium and steep slope condition, they have a lot more scale versus ones that are on the lower end of the slope. So I'm just gonna, I'll keep this actually for now, just again as kind of a reference. but I'm going to just copy and paste this part. Let's disconnect this part. So I just have stuff going into my values to remap in that source domain. But this sets up my values for a graph mapper. So I'm going to go to primitive input graph mapper. I'll plug this into there. Change the graph type to be Bezier. And this is almost kind of literally doing the same thing as that. So if I were to plug it into there, oops, it's probably reading red because there's some zeros in there, which is not what we want. So if I just bump that up, it should clean it up. But again, you can see that all these flat ones, they almost become microscopic. So in order to do that, I want to reverse those and to say that, you know what, I want just the really flat ones to stay the same size, but as soon as they start to vary from that, they start to scale a little bit more. And again, I don't want them to kind of become zero, so I'm going to bring that up a little. I can do something like this. And let's turn off our points here so we can just see a better idea of what these cell sizes look like. So like I said, so the ones that are really flat are kind of staying that same size. So maybe I want to include some more as part of that. So now I start to see really kind of the steep areas getting small, but everything else kind of stays the same. You can always kind of adjust that. So the point is that you want to show some good variation coming from this. So adjust this as needed, right? Like this one almost really kind of shrinks quite a bit, which is again what we want it to do. All right, so now we've rescaled it. Again, we have the ability to make these into three-dimensional objects instead of just sticking with some type of two-dimensional geometry. So let's look at some other things we can do. So we can begin to actually extrude these in a variety of different ways, and it's from here that we'll start to show a lot of other variations in some of those other videos. But for now, again, I want to take these points from my original cells and I can start to give them height or start to move them based off of these similar parameters of the slope. So what I want to do is actually move these points in the same direction of their tangent line. So again, when I looked at this is the direction I want to move those points. So that way it's kind of matching the slope. I could obviously do them in all sorts of other directions, but that might be a little messy because now our logic is no longer clear. So let's just get rid of that. But that is the direction we want to move them. So we have our points, we have the direction. Now we can use the same kind of logic of the slope to say, okay, move the points that are really steep much further than the ones that are flat. So maybe the points that are flat or on these flatter areas don't move a lot, but the ones that are steep move further away. And so we can use this similar part here. So I'm just going to copy and paste. And we want them to probably, so this one's just, in order to move it, they need to have a little more significant distance than a range of 0 and 1. In this case, we can even add a multiplier to say, okay, move them by maybe 5 times that length. So I'm going to go to math, multiplication, do something like 3 to start off. So again, I want to move these points. So here's the move. Again, it just defaults to 10 in the Z direction, which isn't really helpful. So I need a movement and a numeric value with that movement. So this again, where we can use the direction coming from here and give it an amplitude based off of this value to move it. So I'm going to vector, vector, amplitude. So the direction is here. The amplitude is what our graph mapper is giving us. And now that's going to tell us to move those in those directions. So it's already, again, needs some adjustment. So in this case, again, if it's really flat, I actually want it to move very little. But then if it's really steep, I want it to move significantly more. So I can already see that maybe that's a little much, a little too much movement. Let's turn off the original. So this one's going out that far. So let's actually adjust that closer to maybe around the 1 value. And I can create something kind of similar too, right? So it's almost the opposite of that for this to work. But sometimes you have to actually apply this to creating the 3D geometry to really gauge whether it's what you're looking for. So I have these points that have moved to some degree. So again, these haven't moved. The steep ones have moved. So I can go to my surface and look at different ways of creating a surface. So I'm going to use the extrude to point. So it's looking for a base curve, so that's this one. Then it's asking for that point, so I'm going to use this. And this is going to give us these diamond-looking geometries. And don't worry if it's reading red, it's probably just because there's some obscure geometry that's just not translating really well. But all in all, it is doing what we were hoping for, at least what I was hoping for. So you can see that the ones that are, again, kind of steep, they're starting to move out a little bit more. I think I want there to be more range in those ones, so let's actually create to look a little more like an S. Now that I'm creating a 3D geometry, the computer starts to lag on that. So let's just kind of keep it there for now. Let's get rid of this point so we can see it a little bit better. So it looks like it's doing what I want. If I want to kind of amplify that, I'll just drag this up to 2 or something so the values are a little more extreme. Maybe I can kind of include more of these to change. So there we go. Now we're starting to see those really start to kind of spike up. All right, so we've got some gaps in there. So if we look at those original cells, so let's go to primitive, curve, right? So if we want it to actually look like a whole surface, I can take these and create a ruled surface between the two. So let's go to surface, freeform, ruled surface. So now I've got something that's kind of filling in those gaps now too. Still think I want a couple more of those cells. It seems like a lot of them have just stayed the same, so let's actually try to get slightly more range to this. So I'm going to go to this graph, and again, it's going to start to lag with it, but now I'm starting to see a lot more variation with it. And then maybe for the small ones, maybe they don't get as small. So again, where you can start to get really kind of nitpicky with this, and it's all going to respond to these parameters, which is great. So yeah, now we start to see a nice kind of spiky looking surface. I think we found the culprit as to why it's red, is that for some reason that's not working, but that's okay. So I'm going to take these two objects, just bake them onto a new layer, turn it off so we can actually see what this is looking like. Alright, so now here's our surface, where we can see those areas that don't really change, which is cool, and then they start to translate into this more kind of diamond scape. So again, it's pretty easy now to, again, use whatever type of geometry for this, so or different types of geometry transformation. So instead of extruding to a point, I'll just go ahead and delete this. I've got a movement, so maybe I just, instead of moving a point, maybe I just extrude these cells a certain height. So let's go ahead and go to, again, surface, freeform, extrude. So it's again asking for a direction and an amplitude, so I'm going to take these, extrude them with that same value. So I've only really replaced that one, and you'll see that it does the same thing, except instead of it kind of getting tapered off, it just literally takes that shape and extrudes it in that direction. And then from here, you can actually create a surface from those edges. We can try capping it. I'm afraid it's probably not going to work. Nope, because it's not a uniform surface. However, another way we can do it is just say move this geometry in that direction, and from here we can actually use the patch component. I'm going to make these all grafted, so they're all going to create their own individual surface. If it's not grafted, then it's going to try to create one giant surface from all these cells, which is not what we want. So it's going to take a minute. This is one of the more time-intensive components. You could always adjust some of these settings to make it a little bit easier, but it's a little late now. But you'll see it's going to essentially just create these kind of organic caps on all these surfaces. Hopefully, maybe. All right, perfect. So there you go. So now those have been capped. I can do something similar where I take these and these to create a ruled surface as well. So I'm gonna copy and paste that. I'm gonna, actually let's just do it this way. So ruled surface. I'm gonna also graft the first one. So I'm gonna make sure that this gets grafted. This one's already getting grafted, so I'll go ahead and plug it that way. So now I've got a solid kind of extrusion that way. And then again, I've got this part. So let's see what happens now that I bake all three of these. Let's turn that off. Then I'll show you one more texturing of this before we move on to the next series. So again, I'll turn that off, and now you can see that we've got these extruded hexagons, which is a little more rigid and kind of chunky, not as elegant as those diamonds, but it's still creating something interesting. So there's that output. So I'm going to do, like I said, one more. And in this case, I'm going to get rid of this. I'm still going to use this patch tool. So I'm going to actually use the, let's see, where are those originals? So I actually don't want to do it from there. I just want to, I'm going to use the scaled one, and then I'm going to still use that point. So again, I'm going to move these points, these center points, based off of this amplitude. Might be a little extreme, but we'll give it a shot anyway. And I'm going to, so here's a kind of a good trick, because I know what I'm going to do, but it's going to take a lot of processing power if I try to do it one step at a time. So if I just hit the space bar and use the lock or disable solver, I can actually adjust things without it actually computing it. So one of the things that took a while is the number of spans. There's 20 in every direction. So imagine each one of those surfaces made up of a 20 by 20 grid. So it's pretty detailed. So let's do something lower, like 5. And I'm going to, again, graft both my curves and the points that it's looking for. So there's the curves. I'm going to graft those just in case. Now I'm going to go ahead and enable solver. And again, it's going to take a second, but you'll see that now instead of those really sharp pointed pyramids that we had in the first iteration, these ones are going to be these kind of nice, smooth extrusions. So again, hopefully it doesn't take too long. It looks like if I turn it on, I'll see it a little bit better. Yep, it's still solving it. So even though it solved it, it still takes some time to kind of compute. Oops, I actually don't want to, because now it's just creating too many. I think so. Huh. No, that is right. I don't know why they're displaying like that. Let's try not grafting that. Come on. Okay, so yeah, it still produced the same thing. It looks kind of weird, but once I bake it, you'll see it's better looking. Again, I'm going to combine it with this part. Yeah, it looks like I've just mess with my display settings. So I'm going to turn that off and go ahead and, again, bake this. Turn it off. So now you can see that there's just these kind of slight, smooth kind of extrusions coming out versus those really kind of sharp pointed ones. Alright, so this gives you a good kind of starting point. I'll show you just one last thing again, just to show you how easy it is to create these different iterations. I'm not going to use this one because it, again, just takes too long to process, but I'll at least show this. Let's just get rid of that. Let's say you're kind of overusing hexagons. It's not that difficult to replace that. So again, I'm going to go to my Lunchbox plugin. Let's do diamonds instead. So surface. I don't know, I guess that one component really kind of messed with my display settings. So I'll actually save that for the next video of how you can just replace that. But for now, this should help you get started with beginning that process.